And listen, I would like to also mention I'm joined by my great colleagues, Matt Kling and Nahar Nanda from our Burlington campus. So most of the stuff I'll be talking about today, which is pretty cool, was developed by these guys. And I'd like to begin with the problem, and I think I can be brief here given the expertise of this audience, is that counter-drone in many different forms is one of the pressing societal problems or opportunities of this era. And I think you know it, but drone threats, both the productive use of drones, such as in drone first responder, as well as the threat of drones, are increasing far faster than Western defenses can deploy. And at this moment in time, although we believe we at MatrixSpace are taking a big step forward on this, the C-UAS solutions available to users, people that actually want to buy and deploy this stuff, are pretty fragmented. Point sensor products, very primitive AI, difficult to deploy, and very limited scalability, none of which lends itself to the types of problems that people need at this point. And I would come back to the initial point is you'll hear from a lot of people in this industry reference to radars, to different sensors, and all of those things are vitally important, but this is an AI problem, meaning that if you don't really start from an AI native architecture, a data-centric view of the world, it is almost impossible to go into legacy equipment after the fact and bolt this stuff on. So we actually began MatrixSpace as a data-only AI software company back in the day in 2020, and here we are. So the problem is a big one, and it's a hard one. Now, I'll show up some money simply from the importance is a great number of you on the call today are researchers, and it is important to look at, are you research, it's advantageous to line up research where there's rapidly growing markets and where this is right out of, you can tell the market is getting bigger when the sell side analysts on Wall Street actually start to cover it. This is right out of a Needham report, who conservatively estimates the opportunity for counter drone systems at $3 billion today. And I'd point out that's almost certainly conservative. Homeland Security alone has about $1.5 billion of open RFIs for counter drone equipment this year. And that's just one agency, and a lot of the action is going on in Europe. So this is out of the incubator market mode and into the high growth market mode. Now, if you take a look at the problem to be solved, and I'll come back to this later in this short presentation, this is not a technology for technology's sake problem. It's a technology that helps human being problems, and the human factor is essential. A great number of these systems, particularly when you get into the use of widespread radar, are simply too difficult to deploy, and they're too difficult to use. One of the great things that we are really honored to be doing is working hand in hand with many people in Homeland Security, the Department of Defense, now the Department of War, big corporations who are increasing critical asset protection right now. And in nearly all of those cases, there isn't the luxury of having weapons grade, senior engineers or scientists on site all the time. It needs to be easily digested, easy to deploy, and approaching smartphone ease of use right out of the box. And that is not something that has traditionally been associated with radar systems. So mission scale and C-UAS is only the first application of this. There's many more following. It needs to be set up and mobile, right, very, very quickly. Our smallest system can be set up and operating in less than 5 minutes by somebody with a nominal amount of training. And as many of you know, the threat ID, you're now generating tons of data across multiple types of sensors and creating this, if you think about it, a hemispherical bubble for low airspace awareness, mainly looking for drones, but other things too. And the ability not to generate false alerts, is it a drone? Is it a bird? Is it something else? That is a deceptively difficult problem, but that is what people need at this point. So mission scale, scalability, these are movable perimeters. They cannot be rocket science to set up or operate. And that overall problem, while it leverages technology, is all about human beings. How do we make this stuff so easy to set up and use that anybody can do it with an hour of training? Now, to give you a little context, this is actually what is being deployed in support of Homeland Security World Cup games this year. And I'll be very brief here. But on the edge, the AI processing needs to be running at the edge with or without the benefit of a network connection. And it needs to be running on very inexpensive, low cost, and low power compute. There are people now bolting on $20,000 servers to these types of solutions. And it's just not practical. That will not scale over time. It's too heavy, and you need a massive power plant to be running those things. So to give you an idea, that 360 radar system, one of which is on the roof of the Burlington campus, another is on the roof of the Oakland campus at Northeastern University. That entire thing, including the radars, including the hub, including the compute, is well under 300 watts of power. I think the exact number is about 260 on that. The Fusion 360 adds cameras and RFID to that. And the Expeditionary kit, including a 4-pound battery, which is a single radar, weighs 14 pounds. So select the right sensor. Different deployments require different stuff. Deploy them around critical assets, stadiums being one example. But then most importantly for the users, how do you aggregate that data, do complex object identification, a clutter reduction, and threat identification, which is done in the cloud, or it could be on-prem in a server, and push that back down to a user-friendly device to agents in the field, a smartphone, a tablet, a TAC device, right? If you're in DoD, for instance, or a command center, and make that so intuitive and easy to use that you can learn it in an hour. And this is actually what's being stood up right now in support of one of the largest counter-drone activities, C-UAS activities in the world. Now, this is simply a slide that talks about why edge to cloud is so important. And you need it in two scenarios. So particularly in defense applications, you may not have access to a network. You may not have time to get access to a network. So that edge AI, which runs on very low power compute, needs to be very, very capable indeed at doing all of the things that we've just talked about, as well as storing up to, say, a month of metadata that can be retrieved and analyzed later. Now, if you do have a network connection, whether that be 4G, 5G, whether that be a satellite connection, a secure cyber connection for the military, for instance, there is now an ability, if you tap into the cloud, to aggregate all of that data, do even more sophisticated AI processing on it, but mainly to make this look like one thing or one sensor. So whether you have 3 or 3,000 of these sensors, it appears on one pane of glass, easily digestible, and abstracts that in a way that a human being can very rapidly do it. And one of the analogies I overuse is that human beings use sensor fusion every day. We hear things with our ears, we swivel our heads and see things with our eyes. We don't see two fields of view because we have two eyes. Our minds, our brains put that together for that. And that's exactly what AI Cloud does in this situation, only across the hundreds or thousands of different sensors. Now, I'll show you one quick video. By the way, my hit rate of successful videos over Teams is only slightly better than 50%. So if this doesn't work, we'll just continue to move on. I'm not sure if the audio will work, but let me just give this a quick shot and we'll show you a 1-minute video showing this stuff in action.
We are here at Enchidero Park in Torrance, California, to give a demonstration to local law enforcement on the counter-drone technology that MatrixSpace is developing to detect, track, and identify drone threats that are within our airspace.
The Fusion 360 is a multi-layered sensor solution, taking in data from various sensors ranging from radar, remote ID, which is picking up drones that are broadcasting their location and the pilot's location. And then it takes those cues and it prioritizes an optical PTZ camera so that we can put eyes on target and know that that's a drone coming in our airspace.
Drones are an incredible technology, and they offer to do so much good. And we just need to be much smarter about how we protect and surveil that low airspace.
Were you able to hear that? Did that come through?
Yes, that sounded and looked great, Greg.
Hey, one of the few successful audio transfers over Teams video. Remarkable. We're on a roll. So it gives you an idea, and that is exactly right what you're going to be seeing. Portable, you can take that system, put it in the back of a trunk of a car, the back of a pickup truck, and set that up in about an hour on that. The smaller units in about 5 minutes. So in conclusion, this is not, I'll give you a few other examples. That's the type of tech that will be deployed with the Coast Guard to protect our ships at port at the World Cup, which we mentioned. Another area, which is not counter-drone per se, but is actually enabling drone first responder, positive use of drones, is, to our knowledge, the largest distributed AI radar system outside the military in the world. So this covers over 40 square miles in Palm Springs, California, a very challenging area. There's an airport in the middle of the city. The police department is using drones in boxes scattered all over this large territory to get eyes on situations very, very quickly. And to do that legally, you either need a person watching those drones all the time, which is not practical, or you need a radar system on that. So this is another example of where, in this case, counter-drone has a close cousin, which is drone first responder, different application, same technology. And last but not least, we have talked about the World Cup games this year. Now, since many, not all of you on the call today have a research background, I wanted to offer a few thoughts of remaining problems to be solved, or at least improved. What else needs to be invented? And I would offer you that this counter-drone, C-UAS market, you could either say it's at the bottom of the first inning or the beginning of the second. It's becoming a large market rapidly. It's still very, very nascent. So many things need to be improved. We talked about the first one is that this stuff ever needs to be made more simple for a human being. I am a child of the smartphone industry back when smartphones were not easy to use. And today, the out-of-box experience to, configuring and booting up a modern smartphone is about 10 minutes. And it needs to be that way for this stuff too. We're not there today as an industry yet. It is definitely multi-sensory. If you're familiar with the AI metrics of precision and recall and F1, which are metrics of evaluating the goodness of AI object classification, they grow up dramatically if you're using different types of sensors. If you can get radar and RFID and optical cameras on the same object at the same time, for instance, the accuracy of your AI goes way up, very much like we use our human five senses. And I would come back to the practical and tactical. Money matters on these things. The history of radar systems in general has been dominated by the military or near military types of companies who are not good at putting together cost-effective, highly scalable systems on this. So this stuff, as an example, those systems that I showed you previously are about a quarter of a cost of any competing systems with other companies. And this does matter when you start to look at deploying hundreds or thousands of systems. So last but not least, I think that if you look at one of the customer pain points right now, we spend a lot of time in MatrixSpace and helping customers work through this, is customers don't want to be integrators. So coming up with a new mousetrap, a new cool thing that does some new thing that is not integrated or easily integratable, right, to a commonly used industry platform like a user interface or a C2 system is really tough. And it doesn't really help the customer on that. So where possible, I think it's important to figure out how to consistently innovate on top of commonly used industry platforms like AI Cloud, for instance. And this also helps with respect to funding and things move forward.